Whenever you guys are.
Okay, welcome everyone to our fifth Process Control Methods SMIG Team webinar of the year. My name is Pete Tatey. I'm the team leader, and I would like to welcome you to this webinar. And this is sponsored by the Process Control Methods SMIG Team, part of AESQ. Next slide, please. Oh, please, if you could, take your camera and take a picture of the QR code. That'll get you into Slido. The passcode is SPC. And there'll be a few interactions with you on questions. And it'll be a lot of fun if you could do that for us. Appreciate that. And again, I'm from Pratt & Whitney. Welcome. This is the simple agenda we have here. We're going to get into a little bit of an overview of AESQ and our SMIG team, followed by the meat of the webinar, the presentation, and an opportunity for you to have some Q&A time with our panel. Next slide. And the presenters. We have a really great cast here today. First and foremost, I want to thank on the very top left is Ed Briggs from Druck, who helped lead the development of this webinar. Andrew Stout is our co-leader from Pratt & Whitney, Canada. Tony Sweeting from Rolls-Royce, and Ricardo Banulis from Rolls-Royce here in the States in Indianapolis. I want to thank all our presenters for giving their time for this webinar. Next slide, please. Our full team is going to be shown here on the next slide. And again, on our actual interest group website, you'll see this picture and contact information. If you ever needed to reach out to any one of our team members, we welcome that. So this is our team. We're very proud of our team. Today's webinar is recorded, and we would ask you to use the chat feature if you'd like to ask a question at any time, and then please remain on mute during the presentation. And again, this allows us to have a noise-free webinar and mitigate disruption. Next slide, please. Process control methods, RM, Reference Manual 13,006. So our team owns that particular document. It was written to support the process control implementation requirements built into AS 13100. Also, it interacts directly with Reference Manual 13,004, which many of you know is the DFMEA, PFMEA flow diagram control plan reference manual. Also, we support AS 9145, which is the APQP PPAP global standard, as well as AS 9103, the standard from IAQG, the International Aerospace Quality Group, around key characteristics. The reference manual was developed and owned and is in the process of being revised. There's some great improvements coming. Those will be forthcoming in 2025. Next slide. And one thing we'd like you all to know is you can always reach out to us by utilizing the Process Control Methods community of practice. Please feel free to join that community of practice. We'd love to have you part of it. You can ask questions on it. We will get back to you. Feel free to utilize that. Also, we announce all our webinars and any other, questions or subjects that come up that could be utilized by the supply chain in total. You'll get a lot of use out of that community of practice. So please, don't be bashful. Get on there, become part of our community of practice. I'm going to be handing it off very shortly. We're going to talk about the critical success factors next in terms of gaining acceptance, correcting methods, using correct methods, and implementation methodologies and sustaining the benefits. Sustainment, again, the last piece. So I'm going to hand it off now to my teammate, Tony Sweeting of Rolls-Royce. He's a master black belt and a member of the manufacturing engineering group at Rolls. He's going to talk about planning and gaining acceptance. So Tony, it's all yours.
Okay, thank you, Pete. So it was good to see a lot of those answers that you had in terms of gaining acceptance was one of the top ones. So that makes this easier, that it feels like it's useful to talk around this. So I'm briefly going to speak about possibly some of the softer skills side of it in terms of how do you actually gain acceptance. I would presume, especially for the people on the panel, but maybe a lot of you people that are on the phone and on Teams at the moment, you kind of get this stuff. You understand why it's useful. So why does no one else seem to understand and want to do this? Over my many years, for 20 odd years of being a master black belt doing this kind of stuff, I've got some hints and tips and some things that we can say that kind of are proactive and also are arguments against this. And though, you know, arguments is quite provocative, but sometimes this is a good response to have. So I'll start with the first thing. These are just some examples of the kind of thing that I've had over the years and probably many of you have. So the first one really is, well, we do 100% inspection. I know what's good or bad. I quality control what we make. So why do I need this thing called SPC? What does it give me? The counter argument I always say is, well, again, understanding that possibly this is coming from maybe an operational level where it's just about getting those components out, making sure they're good quality and getting that delivery on time. This could speed up production. It's possible if we can show some kind of stability, at least at the beginning, and even control, you never know, that we could speed up production by sample inspection, for instance. Also, inspection can often be a bottleneck. There can be a lot of rework or some kind of iterative process happening at inspection. And for those Lean Six Sigma black belts on the call as well, everyone knows that inspection is a non-value added process. So removal of that can only be beneficial. Now, no, what I'm not purporting to say is remove it entirely, but maybe reduction via SPC implementation might be good. And that all gives you confidence in your capability, really, is what we're saying there. Another big part is, wouldn't it be great to be a bit more predictive? So when you're planning your output, you know what's going to happen. You're not so reactive. I always say when we talk around zero defects or reduction of non-conformance, the only way you'll ever get there is if you apply proper process control, where you are predicting issues rather than reacting. Because if you have to make one before you do something, then you'll never get to zero. Simple maths. The next part would be, the argument we always have is we don't make mass production. We're not making nuts and bolts. We don't gather enough info. Why would I need to apply this? It doesn't seem applicable to what we make in our factory. Counter argument really is, well, to start with, even if it is sporadic, you know, more sort of points in time that aren't as often as even car manufacture, it may be that even that, when you chart it out, you can see patterns or trends. So even if it is fairly rarely, that would still be a good thing to monitor, would it not? It doesn't negate that need. But the other part would be, well, maybe there's lots of information from those individual parts. So It might be the profiles or whole arrays or derived diameters that make up an average, where you're taking many points and averaging them out to say that part's good. There's lots of gold dust within that particular process to tell you, actually, there's something unusual there about just that one component that gives me clues on what I should do to improve it. And I believe Ed will talk later about subgrouping as well. Another bit, why don't we just look at some of the inputs? There may be many inputs to that process that would give you a clue of how you made it rather than what you just made. And that's usually multiple inputs to make any particular thing. And you get it for free. It is not an additional inspection. You will have to make those inputs to measure them and to make something that's the output. Another one that we have as an argument is, well, I haven't got time to do this. Until we automate it, I don't see how we could get to a place where we would properly want to put this in place. So a lot of the time, I think it's sometimes better to start with manual charts. Gives you a good idea to test what really is useful before you go into full-fledged automation of everything. See what does correlate, what would be useful. Also, sometimes in terms of engagement of the people, it is useful because it checks that they are understanding. And sometimes that tacit knowledge that they could write on a manual bit of paper, maybe, again, this gold nugget that you want to capture. So you need to make your automated system good enough to do that as well, because there are only points on a chart until you make them something that tells you something that's useful for problem solving. And like I say, it helps make that charter for what the automation may be. That first manual test may help you. So it doesn't stop you or prohibit you, and maybe it tests the water. Again, there's many arguments, but one of the final ones I often hear is, well, why do I need control limits? I've got specification limits. They tell me whether the product's good or bad. Why do I need these things, control limits? And again, a lot of people get confused between spec limits and control limits. So we'll go on to the proactive bit to help out on this. But the big difference I would say is control limits really are there to tell you what the process has done and what it should do next. It's not about what you want it to do. It's about what it has done that tells you what it's done will do next. And it may be a change for the good or bad, but it at least tells you something's not the same. Again, voice of the process, I'm sure you've heard many times, but it is something that inherently is misunderstood by some people that, you know, it's fallen out of the control limits, it's bad. Maybe, maybe not. It just tells you it's changed. So it's a different thing. It gives you a different bit of information. Obviously, if you're in the spec limits with control limits, you can predict it before it's too late. You know, I've fallen out of my control limit, but not my spec limit yet. Maybe I need to do something to make this better. Stop the process, find out what the reaction plan is. And again, I'll mention inputs. If you're monitoring a lot of your inputs, which is how you made it, you can get that really useful information for free. And also, you might not know how to spec an input to a process. You know that it should operate at 50 degrees, for instance, but plus or minus what? You don't know until you start seeing the output. So that change in the process by control limits tells you, actually, I think these are control limits of what I should keep in order to make a good bit. And when it falls out of that, all bets are off. Okay, so the next slide is more on the proactive side of it. So, right, thank you. So this is, there's quite a lot on here. and some of it sort of bounces around and read across, but this is what would be more proactive. Again, it may negate some of those discussions I mentioned on the previous slide. Starting with the top left-hand side, big thing, my biggest thing I am doing where I work at Rolls-Royce is teaching. It really is. It seems to be the best and easiest way to get people on your side to implement SPC. And when I say teaching, I could possibly say in brackets, selling. I'm trying to sell the wares of SPC. Look at the goodness this gives you. But there is a large part of that which is teaching the basics. And I think there is an understanding, an underlying foundation that needs to be, people need to understand not just what it is, but why you would want to do it. And that's part of that teaching. Again, great that they can work out what the control limits are. Part of that teaching is, why are we doing this? Goes hand in hand with promote as well. And what I'm really saying there is, sometimes you've got to get quick wins. And it might not be the highest priority area that everyone's screaming about within the company. It could be more that this is fairly easy to put in place here. And I can point at it to say, wouldn't this be good to read across to the harder to implement areas with a bit of engagement and maybe a bit of automation and the rest. So think of that effort over effect in terms of implementing stuff, because really sometimes those quick wins are really useful, especially in teaching, to point at and say, this is what it could look like. The next bit would be coaching, and it goes hand in hand with the training, obviously. If you train people, it is incumbent on you to have that support for any process they may then engage in any areas. And also they become a point of contact for you. So you're not the single point of failure, because in many companies, it can be, we've got a few experts. That's useful as consultants, but you can't be running around and solving everyone's problem. You have to have a good spread of people. So that coaching is part of it. It also enables good feedback of where it is best practice being done. Oh, you've implemented something here, let me see. Or you're struggling here, we've got a network here that we've coached. A big part I'm learning more and more as I get older is I don't know much about the digital side of it at all, really. But I should do, and I should be more involved. So engagement of the digital teams, mainly to make sure that they are aligned to whatever SPC strategy you might have in the company as well. Often they're running in parallel, and that's fine, but you should understand and feed into that what you believe would be a good implementation of process control. And at the same time, they feed to you what is actually physically possible with the machines and the people you've got. And again, sometimes the digital teams don't know what they don't know. So they're back to a bit of teaching and coaching of those teams so they can understand why we would want this. We're not just asking for data for the sake of it. But more obvious, bottom left, we've got planning. Goes without saying, but means a lot of the top things, the teach, the promote, the coach, the engage, make that part of your plan. It isn't just milestones of implementing it at problematic areas. It has to be broader than that. It has to be, how do I engage these people? That's part of it. And your biggest stakeholders are going to be the leadership that possibly don't understand all of the benefits of this. So you may need to sell it in a way they can relate to delivery, capacity, resource. What does it free up? What does it give me? It's great that I, as a Six Sigma black belt, you understand this, but how do you sell it to your audience? Building a critical mass kind of covered within the coaching, promoting and teaching. If you're doing that well, you'll be building that critical mass anyway. It'll be the output of doing that, hopefully. That if you've told people how to do it, you've sold it really well, and you carry on coaching them, you'll be building that critical mass of people that know this stuff. And it helps not being the lone voice shouting and waving the banner for this great stuff called SPC. Next bit is really, I kind of mentioned it on the previous slide, but piloting it. Maybe it might not be the area that the leadership are shouting and saying, we really want to get it in place here, really having problems. It might be it's too difficult to do it quickly. So is there an easier place? There still has to be benefits for the reasons, you know, in terms of selling it to people. But think about the areas you may pilot. How difficult will it be? If you've engaged a digital team, they may tell you that certain things are impossible as well. So get that bit of knowledge from everyone, but sometimes it might not just be in the one that's the highest priority. Maybe I need a quick win, in other words, to sell this on a bigger scale. And last but absolutely not least, seems obvious, but you'll be surprised how often it seems to get missed, which is involve the workforce. And really, I'm talking about what I would call the process owners. And really, those people are the people that you involve on all of this we've mentioned. Teaching, promoting, coach, engage them in digital team, make sure they're part of the plan, they're part of that critical mass, they're part of the pilot, they may even help you choose it. But these process owners are the people that when they press the button and they touch this process daily, weekly, whatever, they know whether they're going to make a good product. It helps them predict that. And also, when they know from the control limits that they possibly may not be making a good product, how do they react? That has to be part of it. And they need to be engaged as soon as you start talking about this stuff. Okay, bit more detail on all of that and the implementations and methods and some of the issues you can come up against. My good friend Ed Briggs will now go over that with you. Thank you very much.
Thank you, Tony. Thanks. So once we've got over the gaining support aspects of this, I just want to talk around methods and implementation and some of the pitfalls that we can run into on that journey. So if we go to the next slide, we're taking a fairly analytical look as a team. It might not be totally evident through all the sections of the presentation, but we've used an FMEA type approach. Now, I'll show you this, right? The other teams won't necessarily, the other team members won't necessarily show it in their sections, but in order to look at the methods and implementation, I've found it personally really helpful to look at what the actual purpose of SPC is, to get down to actually what is it we're trying to do with this type of tool set. And if you look in the reference manual, it talks about closed loop mechanism. It's a closed loop mechanism that recognizes process anomaly. So those who are not familiar with the word, it's process behavior that's indicating instability. It's unstable behavior of a process. So in recognizing that, what SPC is trying to do is trying to drive some corrective action. So recognize it. If it's bad, do something about it. If it's good, recognize it and set a new standard. So that's the basic function. So if you think about how that can go wrong, I mean, obviously there's many things in different systems that can go wrong, but fundamentally, we took the view that there's three things that can go wrong there. So first of all, in the second column is the failure mode in the FMEA. So anomalies or process behavior not acted on. So if we get instability in the process, it's not acted upon. The second one is that it's recognized, but the people that are operating the process are unable to fix the problem. So you can see all around you instability, but nobody is able, for whatever reason or another, to actually do anything about it. And then the last one is that actually I suppose it says tampering, that uses the term tampering, which some of you might be familiar with, but what that amounts to is taking the wrong course of action. So actually reacting and taking a course of action that's inappropriate, and that then ends up with the process being upset in some way. Okay, so they're the basic three failure modes. There's a few causes on there on that slide and a few countermeasures. I'm not going to talk through those, but what I'm going to do on the next few slides is just pick out a few of those, helping to relate it back to which of the failure modes it relates to. So we've included these slides again in the back of the pack, and we can put these on the AESQ website if they're helpful. I don't claim that this is an exhaustive list, but this is just hopefully thought-provoking. So if we go to the next slide, please. So if you think about the actual purpose of SPC being that closed loop mechanism, helping us to recognize abnormal process behavior and then respond to it, the flow chart on the bottom right really sums up what we're trying to do. We're trying to put something in place at the to measure the process, to check for process anomalies. Then we're going to take some course of action. So first of all, we've got to decide what to do about it. Then we've got to take action, remeasure the process. Hopefully that's returned us to some kind of stability. So in that closed loop system, if you think about where you actually place the SPC system relative to the actual process that's doing the work, it's really important to make sure that closed loop system acts quickly, because what we do see, well, what I've seen from time to time is a tendency, because we might be inspecting at the end of the line. Maybe we're using a high precision piece of equipment like a CMM. On the face of it, that's a good point to get SPC in, because we can see what the process is doing very precisely. It's probably easy to implement SPC systems and software. However, what that results in is some of the bullet points that you see on the slide there. So first of all, if your process is much further upstream, measuring much later introduces a huge delay into that. So that of course means that the person that's doing the measurement is not the person that's doing the operation itself. So there's a potential for lack of communication. You're liable to get a lack of feedback to the operator. You're less likely to solve the problem because of the delay. So the problem may have been a temporary issue that's maybe seen as gone away. If it's a problem that's ongoing, then the delay causes you even more problems, because what that can result in is an ongoing problem that's not recognized until the point of inspection. So that can create problems with increased WIP that's affected, and then the operator involvement is compromised. So when it comes down to actually fixing the problem, because of the lack of engagement with the process operator, it's very difficult for the process operator to get involved in the problem solving process. And the reaction plan, we'll talk about in a few slides' time, but the reaction plan, the prescribed response to an issue, will probably not be very useful, because if you think about your average inspection area, there's the one thing that we don't assure there is that the sequence of production is necessarily the same at inspection than it was at the operation itself. So parts can come into the inspection area out of sequence. There can be a mix of different machines, different sources of product, which all usually will cloud the picture of what the actual process is doing. So the clarity about how the process is behaving is lost. So actually the real lesson in this is to put the SPC system at the operation. That's the point where the SPC system can be most effective and actually fulfill its purpose, which is on the slide there. Now, one of the things that can be a barrier here is the precision of the measurement equipment, but I would just urge people to think beyond that. Don't necessarily just automatically jump to the conclusion that because the part is measured on a CMM at the end, that you need a CMM at the operation. It could be that there's I've certainly seen it in my time in industry, that actually a system of SPC using a gauge which is maybe less automated than the CMM, actually placed at the front of the process by the operation, can be much more effective from a quality perspective than just waiting for that precise measurement at the end. So the next piece here, really, I mean, I've seen this many times in my career, when SPC systems have been trialed, and it's back to, if you think about the purpose of the SPC system, is to recognize unstable behavior and then be able to do something about it. So I always think that an SPC system to be at its best in terms of implementation is implemented into a stable environment such that it can maintain that stable environment. So naturally, processes want to do what they want to do, not what we want to do. So there's always a tendency for chaos to take over time. But if you've got an extremely chaotic environment that is not got any stability to it at all, so some of the points on the slide there on the right. So if we've got methods that aren't standardized, so everybody does the job differently. If we've got machine tools that aren't properly maintained, they're in a state of disrepair, fixtures and tooling that aren't adequately maintained, or material standards not understood, environment, some different processes obviously have different environmental requirements, but if generally speaking, the worse the environment, the more that's likely to wreak havoc in terms of your quality, especially in precision part manufacture like we are, high precision. The environment is often a very, very important factor, as well as the measurement equipment. So there's a few ideas there. There's a few suggestions. These things actually, it's really helpful to have those well standardized so that we're putting an SPC system into a stable environment and then maintaining it. If we put SPC into a very unstable environment, sure, the operator will see that things aren't right. They'll see the instability, but quite often, if they're working in a state of in a really subpar environment, they'll be powerless to actually make a difference. So sure, SPC can inform us of a lack of stability, and then we can take some action. But sometimes it needs to be a bit more systemic than just the operator recognizing a point is outside a control limit. It needs to be management and leadership recognizing that the real the real success factors in terms of hardware and process and standardization. So the picture on the left there, it's not necessarily an aerospace example, but hopefully it kind of gives you a picture of, you know, what some of the aspects that you might need. Now, of course, there's no perfect time in this. It's not as if you can suddenly get to a point where you can definitively say now's the right time. But what I would say is it's to delay getting that stable environment isn't going to be helpful to you at all. So, you know, whilst you might say that you might do a few things as a precursor to implementing SPC, it's really important to start now on those things, because you know, they're never going to fix themselves. Some businesses I've worked in have had diagnostic assessment tools. I think they're brilliant, actually, because by asking a few thought-provoking questions, the teams can reflect on the answers they get. So you know, just there are, even if you don't have those in your company, yeah, maybe your big customers have those. Certainly, I know Rolls-Royce, from my time there, do have that kind of thing. But it's that kind of mindset about maintaining standards that's so prevalent there, and that can be really helpful. So just to re-emphasize in the point, in the reference manual, there's an introductory section that talks about this. It talks about the importance of having a fundamentally capable process. And what I mean there, the top part of that pyramid is picking technology that's fundamentally capable for the job. SPC won't fix an issue that's a capability issue. It's in the middle of that diagram. There is a range of control methods that can be used. Not all of them are SPC, but the foundational activities, you know, it talks about creating a stable environment. So it's, you know, it may be worth you picking up the reference manual, having a read of that introduction. That might be helpful. It might help you be able to sell that concept, and help with some of the issues that Tony was describing there. So the next thing, again, along the same lines, you know, actually knowing what to do when you see the signal. This is, you know, this is looking at a control plan. This is looking at a document. So it's a bit dry maybe, but it's very important that we recognize certain process behavior through the SPC chart, but then we react in the right way. So, you know, at the top there's an example that's very, you know, very scant information there. You know, it talks about if you recognize something that's wrong on the chart, call manufacturing engineering, follow your non-conformance process. It's not telling you anything about what pattern or signal you want to be reacting to, and it's not giving any guidance about maybe any initial recovery steps that may be taken. It's just saying call someone else. You know, it'd be great from an engagement point of view. And this comes to the second point. If the operator has a set of recovery actions that are defined, so if the process drifts, maybe it breaks rule 5, is it, or of the Western Electric rules, that they check changes around the start of the run. You know, let's look back 8 or 10 points and see if we were aware of anything changed. Maybe we could check the tool for damage. Maybe we could check other factors. But in that situation, that second control plan line items a lot more prescriptive. It's a lot more informative. And, you know, if you get to the point where you can't find the problem, then maybe you need to call for help. But at least it's giving some guidance on certain things to check beforehand. If it's just a case of call ME or call a supervisor every time something goes wrong, you know, the brain power of the organization isn't not necessarily being leveraged to best effect. So we always say, try and make the reaction plan as informative as you can. That doesn't mean to say that all of the text needs to necessarily go in the box. You could have a work instruction to guide you on how to react to certain behavior with more guidance. But think about, well, what would I do if I saw this particular type of behavior? Realistically, what would I want to be looking for? What would the lines of inquiry be? The next one's a bit of a techie one, actually. I must admit, I didn't want to make this overly technical, but this is one that I've seen many times over the years. So this is the tool being the wrong tool for the situation. So the scenario here is that we've got a fairly high volume process. Excuse me. We've implemented a basic IMR control chart. Now, that process looks very, very unstable on the face of it. And you could react and say, well, that's completely out of control. That's complete chaos. Until you understand actually that process has got a natural behavior to it that's cyclical in nature. So the variation that you see in the very short term is not the same as you see overall. So the operator in that situation with that particular chart is going to find that very, very confusing, and they're going to be drawn into reacting in the wrong way. So they're going to be, trying to make adjustments that might not be the right course of action. So what's actually going on in that situation is that there's a batching effect. There's a natural, and this isn't always just about batches. This could be a source of variation that's completely natural, but at certain points it's fairly cyclical. So within the batch, the process runs in quite a stable way, and then between batches there's a source of variation like a setup or a tool change or something like that, and that source of variation is completely inevitable, and it's part of the process design. It looks on the previous slide like special cause variation, but in actual fact it's actually common cause. So there's a couple of different tactics you can use with this. One is subgrouping. So you can use a different chart that looks, and if we go to the next slide, I'll show you a good example of this and a bad example. So this is using the same data. What the specialist has done here is used a subgroup chart called an X bar and R chart. And that's a fairly standard chart in industry. You can look that up. It's in our reference manual. But the problem with it is it's got some assumptions to it that assume the variation overall is pretty similar to the variation within the subgroup. So I won't get all technical on you, but what that results in is a narrowing set of control limits around the averages that are plotted. And now that process looks as if it's completely out of control on the average chart. Now that's simply because the assumptions that the chart needs in order for it to be effective have not been met. So you've got to be quite careful about that. I would imagine that on this call, most of you are probably aware of that kind of thing, but maybe not all of you. If you go to the next chart, please, Rodolfo. Next slide, please. That's it. Thank you. This is a chart that's more useful in that situation because it doesn't have exactly the same assumptions. So this is one that we call a three-way chart. So the chart on the face of it gets more complex, but it's actually more useful. Some SPC software packages have this functionality, some don't. So if you're in this situation, I'd strongly advise you really going through the specification for the different, if you're assessing different software vendors, The tool's got to work for you. If it's just an IMR chart and you're in high volume batch production, maybe that won't work so well. But what this chart's doing now is looking at the variation within the batch. That's the chart at the bottom, and then the average chart is at the top. That's looking at the average over time, and then the middle one's a moving range chart around that average. So I'm not going to explain it in detail. If you look in the reference manual, it uses this chart, can be useful in a number of situations. There's a whole section on it basically. But now what we can see, this is the same data plotted on that chart. We can see a stable process. So now if the process does something that's genuinely different from what it normally does, genuine special cause, you're more likely to see it. Okay, so the lesson learned in that is to know the sources of variation in your process. The other aspect to using the right tool for the right job is sometimes sometimes you can get away without using a statistical chart. So RM 13006 suggests that pre-control charts might be useful in certain situations. Again, it's not a case of saying that that's the perfect tool for the job, but in certain situations it can be useful as well. Okay, so, and again, not an exhaustive list, but a few things to hopefully take away from that. So I'll now hand over to Andrew Stout, who works for Pratt & Whitney as a Six Sigma Master Black Belt.
Thanks, Ed. I'll take it from here. I'll cover how to sustain the gains, which can be the most difficult part of any initiative, as probably many of you have experienced. You can get some excitement going when you start a project, start an initiative, but over time, the resources get pulled away, the excitement starts to fade, and other priorities can take over. So how do we sustain it? To sustain any activity, there are many different aspects to consider. I've got some of them on here. So have you seen an SPC program that failed to be sustained in your experience? Starting on the left, we've already talked about training and coaching. Certainly come back to that. That activity needs to continue with the SPC program, for sure. Not having a sustainment culture will likely show up in more than just your SPC program. If you're missing that sustainment culture, you'll have that issue in many different ways. Developing a performance improvement mindset, having leadership visible support, and ensuring that SPC systems are sustained are other important aspects that I'll touch on. So as Ed showed earlier, we have an FMEA sort of model that we've got in the background. I'm not going to go through all of this, but just starting with the looking at the left side. So in this approach, we identified the function here is SPC program maintenance, and we've identified 3 failure modes: SPC operated incorrectly, SPC system fails, and SPC is not reviewed or maintained by management. Then we've identified many causes and even more countermeasures, which you can think of as being controls, and they will help sustain the SPC program. We'll go through some of those. So the first failure mode is SPC operated incorrectly. You can mentally check off these countermeasures if they happen in your company. So first, only using trained people, including both the operators and the support people. Check or no check. Leadership drives improvements, including those related to the SPC activity itself. Is that happening? Operators are empowered to stop the job. The criteria for stopping should be defined and supported, ideally, with an and-on system in order to get quick action. And with the and-on, if you're not familiar with it, it escalates up the sort of command chain until action is completed in a fairly short time. Finally, coaching is used to enhance skills and knowledge, as Tony talked about earlier. For a really good video, and I highly recommend this, see the TED Talk link that I put in here, and you'll have access to that when it's posted on the site, or maybe we can provide it earlier than that. But if you don't know about coaching and you want to learn, if you're doing coaching and want to get better, this is a great video to help with that. And I learned a lot from it, and I highly recommend it. A second failure mode is SPC system fails. And we'll talk about the countermeasures. Are these countermeasures implemented in your company? Again, do your check or X. SPC software and hardware maintenance is built into the IT plan. Not only avoiding obsolescence, but also being aware of better options that become available. And if SPC is paper-based, which is a great way to start, by the way, maintenance is planned. The worst thing is running out of sheets for plotting results. That puts a quick stop to the data collection process. But as long as you have someone assigned to do it and it gets done ahead of time, that can easily avoid that problem. Next. Finally, the third failure mode I want to talk about is SPC is not reviewed or maintained by management. And do your check in the box if you do these, or if you see them being done. Sustainment is part of the culture. Is leadership involved on a regular basis? And during the planning meetings, discussing changes to the system, is leadership involved? That's quite important. The next one is leaders visit the Gemba. What's Gemba? The place where the value is created, the operation where it happens. And they promote SPC. Is that happening? We'll talk a little more about that shortly. And the tool to help with that really is something called Kamishibai, Japanese word. And it makes it easy to sustain activities. It makes it visible when they're not, like shown in the yellow circle. And we'll see this more on the next slide, how that works. Next. The Kamishibai board is a method of process confirmation that can play an important role in the daily management system. How you do things every day, keep things done so things don't get forgotten and things don't get missed. So the board is a simple and visual way to ensure that the things that need to get done actually get done. And they could be simple, very simple activities like sweeping up the area and taking out the garbage. But in this example, we're talking about SPC. So how do we make SPC get done? So first of all, we'll understand the process, and then you can think about how it could apply to statistical process control. So just in a nutshell, you identify the days of the week across the top and create a set of cards for each day. Each card has a green on one side and red on the other. It has the activity name, how to check, and the standard to check against. Or, as shown on the far right, you can have a QR code to scan, and that would bring up the information that you need on what to check and how to check it. So how it works, the identified person takes a card, should be the red side, look at the red side for what to do. They go to the Gemba with someone from the area. They would check against the standard. They would identify if an action is needed, and then replace the card green side out, and that indicates that it's completed. And then leadership should be checking this board every day, or upper management might check it every week to make sure that it's actually being implemented. And there's a lot more to it than that. That's sort of a high-level view. Hopefully you can get an idea of how it could be beneficial for sustaining activities. There is a link to a video provided with this presentation, but there's many others. If you do a search on YouTube, or you'll find lots there. Next, please. So in summary, to make an SPC program successful, we've talked about ways to first gain acceptance by understanding how to respond to frequently expressed concerns, and by taking proactive actions like teaching, coaching, planning, and involvement. That'll be successful. We also covered correct methods and implementation, such as implementing SPC at the transformation operation, where the decision made can improve quality. Also stabilizing the manufacturing system, having a good reaction plan, and using the appropriate graphical tools. Finally, how to sustain the gains or the benefits includes keeping the training and coaching going, maintaining the hardware, software, or paper. It includes empowering employees and leadership that participates and promotes the process control tools. To get leadership active involvement, you may need to convince senior management of the benefits. One of the feedback in the chat talked about that. Well, how do you get this going? Top down, bottom up, maybe both, as I think Tony responded. And how to flow it down. If you go to senior leadership, convince them of the benefits, have them flow it down to their people leaders. It can be a good way to get it going. But the trick, as Tony mentioned, is selling it, promoting it, getting the agreement to push it. So as mentioned, we have these FMEA style slides that cover additional causes and countermeasures that you might find useful. They'll also be available in the slide deck for your use. And these webinars are posted to the AESQ website, with both the slides and video being made available. On this page, we're starting with gaining acceptance methods and implementation.
Mm-hmm.
And finally, I'm not going to go through all these, but just show you what's there. Next slide is the sustainment one, which I showed a bit earlier. And now I'll hand it over to Pete Tatey to wrap it up.
Thank you, Tony, Ed, and Andrew. Excellent. One thing in Andrew's piece that I was just thinking about, there's certainly an interaction with another webinar that we provided last year. It was called the 1 hour process control assessment. May want to check that out. That could be a good help in the sustainment piece. We will also be putting a checklist on the supplementary materials page soon to support that 1 hour process control assessment. With that said, questions. I noticed we had a couple on the chat, and one had to do with is there control limit formulae anywhere that spells out how we calculate the control limits for the different control charts? That's an easy one. I'll take it. It's section 13 in the reference manual 13,006. That lays out all the formulae for every control chart that's covered in that reference manual in quite good detail. Another question came up: do key characteristics require SPC? And so if you go into AS 13100 section 9.1.1.1, that is the section around process control methods, and it clearly defines that key characteristics have to be shown to come from a stable process, along with the measurement systems need to be assessed per RM 13,003, and process capability achievement of at least 1.33. And so that's in the reference, that's in the standard AS 13100. So now let's open it up for, you could utilize the chat, you could utilize, or just ask. Feel free to ask questions now to the panel. I'd love to hear what you have. Let's see what we got here in the chat.
I think while you're digesting that, Pete, if I could just elaborate just on the point that you made about key characteristics, I think it's quite helpful to think about this two ways. So one is traditionally customers have asked for capability information, CPK, PPK values. I think it's important not to lose sight of the fact that what the key characteristics are. So they're the characteristics that are performance critical. So they drive the performance of the product quite often. You know, they're the really kind of the most important characteristics on the product. And you know, the customer quite often is really sensitive to variation in that. So it's not just a case of, well, to meet the requirement, and maybe it's okay to just send a CPK value to the customer periodically, but to meet the true intent of it, it's to have the process controlled at the point of process, so that you've really got that process optimized in the most stable state for that particular product to do its job in the engine.
Well said, Ed. There will be, I'll add just one thing to it as we are getting ready to go through the ballot for AS 13100. There's a lot more meat, if you will, on the bone of the stability portion and the process control piece, as opposed to just the capability index. And so, point well taken. Capability index is one thing. The stability of the process that the index results from is actually even more important.
I think the comment I'm just looking at the chat, Pete. I think the comment here around there's a couple of standards mentioned, 9102, 13100. I think it's a really good point that's made there. Is there a way to clarify that in AS 13100? And it was all about the point that stability is really essential. I think that's my take on it. So I think the comment in itself, albeit there's a question, I think the comment in itself is very powerful.
Okay. Questions? Seeing anything in the chat. There was a question that came up early in the webinar from Tim. Shouldn't the leadership buy-in be the first item in implementation? Top down rather than bottom up. What do you guys think about that?
Well, I replied in the chat in terms of it. All I said is it's another thing in terms of building and selling it to everyone. A lot of the problems can be not leadership, believe it or not. It can be when you're actually trying to apply it and getting the buy-in from the people that use it. So hit it from all sides as much as you can. Obviously, any initial plans, you're going to need the leadership because there may be capacity cost involved. But in the end, the person that is going to use it really needs to be your focus of buying it, because you need to walk away at some point and they'll be the ones that keep using it.
Deming talked a lot about, the language of SPC and communicating in that way, statistically thinking. And one thing for sure, we don't need, and we're not advocating that we turn every operator into a statistician through the use of SPC. That's not necessary, right? But there needs to be solid standard work and basic training on how to react to an out of control process. We need to be able to recognize an out of control process. That goes to the point Ed made in one of his slides about assuring that SPC is done as early and upfront as possible at the transformation operation, where we're converting raw material into something closer to what the customer's willing to pay for. And that's where it's going to have its greatest value, not 5 operations later after the transformation's already been done. And so, and Andrew spoke a lot about management doing a walkthrough and asking questions when they see, you know, the board that was shown. I'm going to just call it the K board, okay, because I can't remember the actual name, but the K board he presented. If I see a lot of red cards, that's a signal, that's a control. And what's going on? These things should have been done yesterday. How come they're not? What's holding it up, and how can I help? So, you know, so building standard work in a culture is going to be a really big part. So it does work both ways, top down and bottom up. Questions?
What's our next question? Have you got the chat, Pete? Can you see the questions on the chat?
Yeah, and I'm not seeing any further questions.
I can see quite a few. Do you want me to read some out?
There's something wrong with what because it says you can't send messages because you are not a member of the chat. So maybe I don't have visibility.
Sure.
Go ahead.
I can take one of the questions from
go ahead.
Say any guidance situations where KC are not identified on the product definition. So we have we've been this issue here in Rolls-Royce where we have a legacy product where the KC were not identified in the drawing, right? Is unclassified drawing, right? So we're engaging with engineering to say, hey, this is the benefit of implemented process control and capability to see if they can change on the drawing, identify life limiting performance characteristics they want us to control in a better way, right? Also, another way that we're trying to implement this is by doing our own PFMEAs, right? When we have issues, when we move material from one part to another, we are doing PFMEAs as part of the APQ PPAP. Once we do the PFMEAs, we can identify process key characteristics where we can implement SPC and process control and capability. So we're trying to deal this in different angles that we discussed briefly before. One is through engineering, and the other one is through process key characteristics when we make changes according to APQ PPAP.
Do you want me to pick up the next one? I'll pick up the next question.
Can you just recite the question?
You can't see it. You can't see it, can you, Pete? Okay, so there's a question here. There's a question here from Jeff. He says, how do you deal with a very tight tolerance, critical or key characteristic, which will never achieve a CPK of 1.33 or better due to this tolerance? But this characteristic is inspected 100% in final. Is this sufficient? Do you want me to have a go at taking this one, or does anybody else want to?
Well, I'll real quick, and then, turn it to you, because this is a big one. The 100% inspection at final, that is a detection-based control, no question about it. We also know that 100% inspection is only 80 to 85% effective. So that in and of itself never makes me feel comfortable. When I see 100% inspection as a control on an FMEA or a PFMEA, I'm going to look for some other means of control to add as an insurance policy, if you will. Targeting nominal is also a very good approach. Guard banding within the tolerance. I'd also want to know what the measurement system capability is If you don't have a process that's purely capable, then the measurement system capability is going to be very important. And especially if you start getting near borderline of the spec limits, because that's where you're going to have the greatest chance of making a type 1 or a type 2 error. So maybe there's, if the process isn't 100% capable, if the CPK, if you will, or the PPK is less than 1, then it's even more important to have the control chart in place and to be, looking at what the trends are and mitigating the chance of getting close to the limits and targeting nominal. So, Ed, I'll turn it to you.
Yeah, I mean, I think along similar lines. I think it's probably helpful to look at this from a supplier's perspective rather than a customer's perspective, because it looks like the situation that you're describing there, Jeff, is you've got a borderline capability anyway. So if you are very highly capable, your process has got more latitude for drift and change before it becomes a problem, if that's the type of process behavior you get. If you're in a situation where your capability is very borderline, then the slightest shift, the bigger the shift, the higher the proportion of defects, but it actually rises exponentially. So your process is very closer to a problem, I guess, is one way to describe it. So I think for me, I think that lends more weight to actually having a point of process control on it to monitor it. Now, if you've got a if you're in a borderline situation where you can't achieve a 1.33 CPK due to tolerancing, then also it might be a time to have a discussion with the customer, who may be able to do something with it. I don't know whether that's your experience. Your experience is good in that place, but certainly there's two ways of achieving process capability. One is higher technology, greater technology, and better control, but the other is the tolerance. The maths for process capability is basically your tolerance band over your process variation. So you can influence it by both of those things.
If I could just add a bit to that, there are a couple of paragraphs in the AS 13100 that talk about this issue. It certainly is an issue that people have. And another consideration might be the gauge itself. What's the gauge capability? And maybe a better gauge would give better visibility at a finer level, higher resolution. That might be a solution to consider. But good question.
You got to also look at the economics of it too. Depending on what the remaining contract is, you might decide to live with that lack of capability, and you could ring fence inspection, 100% at the transformation process, 100% at final. That's, again, that's more expensive in the sense of adding inspection, but again, depending on this, if this is something you're going to manufacture over and over and over for the next 5 years, you may want to invest in better gauging, better processing equipment. But if it's something that you have less than a year or a year and a half with, then those costs might not be justifiable.
There's a question. There's a question at the bottom here just come up around CPK and PPK targets. Just the Windows just obscured the chat for me. Here we go. So I'll read the question. Why is PPK target the same as CPK in brackets 1.33 in AS 13100 clause 911 1? It means that there is not batch to batch variation. Is it? I think what you're getting at is that PPK is seen as long-term variation. It's calculated a different way to CPK, despite the one being more of a short-term estimate and the other one a long-term. Why are the targets the same? Hopefully I've paraphrased that question. Would somebody want to take that question?
I mean, we have a webinar that we did this year earlier called the 3 C's of SPC, and we touched upon that particular subject matter, the difference between PPK and CPK. Also, if you go on to the supplemental materials site for RM 13006, we added a pocket guide this year for the Portland conference, and there is a nice one pager around the difference between the use of CPK and PPK. But again, the difference is sigma, right? Sigma long-term or sum of squares versus the sigma hat, which is based on the short-term capability. In that webinar, we talked a lot about the absolute control of the nuisance sources of variation on top of measurement and machine. But what influences the average are nuisance sources, temperature to temperature, setup to setup, raw material batch to raw material batch. Having those sources under control using process control, standard work, standard setups, zero setups, permanent setups, temperature controls, things like that, that can control those nuisance sources that go over time, you're going to get the long-term variation ultimately to equal the short-term. That is the goal. And that's reflected in a control chart that's in statistical control. This is why we value stability and process in control more so than capability. Because if you have an in control process, short-term and long-term variation are going to equal out. It doesn't matter what index you use, whether it's CPK, PPK, C sub P, P sub P, it doesn't really matter.
I think Pete, I think it's Dusan that's asked the question. I think they understand the technical aspects of it. I think it was around. I think it's maybe something for us to take away as a group and look at that. I think just a bit of feedback again. If you've got a specific situation that probably needs explaining, have a discussion with the customer and see whether they'll take one metric over another. But ultimately, they're after good capability, so it's about maintaining it, isn't it?
I mean, in the automotive industry, they typically would front end load with a CPK of like 167, knowing that the long-term capability will degrade to 133. Over time, and that's why they want in their PPAPs to have that capability to be at a higher level initially, right?
I do think Pete and Dusan's from automotive. Thank you for that. Yeah, I'm just reading here. Yeah, I think this just to add one more thing, and then we'll move on to the next question. I think the key to this is in process design, is in the APQP, the phase 3, the process design, where you should be in the early stages understanding the ultimate capability of the technology that you're going to use, and then anticipating what are the sources of variation over time and how are they going to influence the overall capability. So I think there's a case of actually you need to think about those factors early on, because when you start off with a process, and again, the reference manual mentions this, over time, the sources of variation are only ever going to increase. That's usually what happens. So more operators, more machine tools, etc., batch to batch, longer term, cyclical, seasonal variations, and so on. So I think it's very important in the early stages of process design to start to anticipate that.
If I could add a bit on that, I know somebody will go on, but this is an important question that I think is. I know we've had a lot of
I'm just
discussion.
mindful, Andrew.
Yeah,
Just mindful. There's another couple of
Andrew,
questions.
It's an important question, though.
Okay.
Go ahead, Andrew.
I would say to wrap that up, PPK is more of what the customer sees. It's also more robust to a slight out of control situation, and it can be derived from non-normal data as well. So there are a number of advantages of it, and that's really why we're moving to PPK as more the standard than CPK. So, but it's a transition.
Yeah. Okay, I think we have time for one more question. Ed, if you have, please go ahead.
I've got one simple one. It's very much along the same lines. I'll read it out. If my total tolerance itself is only 10 microns, so the person is talking about a very, very minuscule tolerance. For achieving that SPC, what considerations do we need to follow or bear in mind? So it's talking about continuous production with a very, very tight tolerance of 10 microns. I'm not sure what the actual process is, but 10 microns is quite tight, isn't it? So
yeah,
sure is.
Yeah, so what is the actual question?
I think the question that's been implied is if the tolerance is really, really tight, almost seen as unachievable. What's the guidance?
Talk to engineering. Get the drawing changed.
I apologize if I've misinterpreted the question. Obviously,
no, but I mean we see this a lot. We've all experienced it. Anything that's, and I think we touched upon it earlier. Anything that's very tight, you can at least still be applying. First of all, gauge capability. So the measurement system has to be aligned with that very tight tolerance condition, and it has to have the properties required to have an accurate measurement. That's first. And then, control charts are even more valuable in a case like that. Trying to target nominal are really good strategies, even if the process isn't going to be capable 100% of the time or where we would like it to be. So I think
so you're talking about
minimizing the loss. We're just about out of time. 2 minutes.
We'd like to wrap it up, and folks, we want to thank all of you. Excellent questions. This presentation and the video will be posted on the AESQ website probably within the next couple of weeks, so you'll be able to access it. And please go to the past events site, and you can have access to all the webinars for free that have been not only put out by this subject matter interest group, but the other subject matter interest groups. You are free to utilize that material. With that said, I want to thank our panel today, our folks who presented, and all of you who participated and came to this webinar. Have a great rest of the day, everyone. Thank you, and we look forward to seeing you again.